Hi everyone, welcome back to Xcoding with Alvian. In this video, we are going to build a real-time inventory tracking SwiftUI app using Firestore. Firestore is a NoSQL document database built for automatic scaling, high performance, and ease of application development. It can sync data across devices, Android, iOS, and web, on or offline. It is a part of Firebase, a platform developed by Google for creating mobile and web applications. It also is a serverless database, so we don't have to create server and manage the database by ourselves. Now, let me show you the demo of the app that we will build. Here, I have two simulators running at the same time. So let me configure this side by side, and let me open this Firebase local emulator suite web admin. And as you can see, the list of inventory items is synced across devices here. So let me try to add a new item using this iPod Touch simulator. Boom! It immediately syncs the data across devices in real time, just like magic. Next, let me try to update the data here in the iPhone 13 simulator. Let me change this MacBook Pro 14 to 16 M1. And as you can see, it updates the data in here, and as well as the local emulator dashboard. Nice, right? So we can also edit here and delete the item. As you can see, it deletes the item across the devices. And another option is we can manage the sorting here, whether we want to sort by the name here or probably the quantity in descending or ascending order. So that's basically all the features that we are going to build in this video. You can download the completed project from the GitHub repository that I provided in the description if you stuck with something. And then you just make sure to provide your own bundle ID and Google Info plist to the project. I'm using Xcode 13.4 for building this app. Next, let's prepare all the prerequisites before we can start coding. So let me close this simulator as well as this local emulator suite. First, you need to sign up to the Firebase in here. So this is the website firebase.google.com. So after you sign up, you can go to the console in here, and here you can add a project, give it a name. I'm going to give the name of inventory tracker. Okay. And I'm just going to disable the Google Analytics for this tutorial. Let's wait for it to create the project. Okay, now the project is ready. Click continue. Okay, it will open the dashboard in here. So the first thing that we need to do is to add an app here. We can add iOS or Android or probably web. And it also supports Unity as well as Flutter. And let me add for the iOS platform. And here we need to provide the bundle ID for our app. So in this case, I'm going to use gom.alvenlosari.inventory tracker. So this will be unique bundle ID for my app. And the nickname, this is optional. Don't need to provide it. This is also optional. Then click register app. Let's wait. Okay. Next, we need to download this config file. So download it to your computer. And just remember that we will use this letter, and we need to copy this into the Xcode project basically. So the next thing that I want to show you is using a Firestore local emulator. Let me stop the current running one. Let me open a new tab in here. Let me open the documentation. So basically this Firebase local emulator suite is a tools that developer can use to build and test apps locally using Cloud Firestore, real-time database, cloud storage, authentication, and so many more. So with this, we don't have to hit the database in the Google server. And that is very, very useful when we are in the development stage because there are many data maybe we want to experiment with. So it won't clutter the database in the cloud. It will also save us bandwidth as we don't have to connect to the Google server. This Firebase local emulator suite basically will just set up a local web server that we can hit from the app. So to install this, you can follow the documentation here. So basically you need to install Node.js version 8 or higher and Java version 11 or higher. So basically that you can just use install using brew install Java 11 and brew info install Node. This will basically install Java 11 and Node.js. I already installed that in my machine, but please do it in your machine before we can start using the local emulator suite. So after that, you need to also install the Firebase CLI. So you can just use sudo npm install globally here, Firebase tools. Let me try, is it correct? Firebase tools. Yes, it's Firebase tools. So after you install all of this and as well as the CLI, you can basically use the emulator. Let me cancel this. Okay, so here I already installed it in my machine. So it's using the version 11 for the CLI. And just make sure you list the project first, Firebase project list. And here it gives you the list of all the projects that you have created. And currently the project that I'm using is this Xnews 11566, but this is the one that I just created that and I want to use. So here we need to change the selected project using Firebase use and just copy this, the ID of the project. Firebase use this one. So it's this now using this project instead of this one. And now finally we need to use Firebase emulators in it. Forgot the syntax. Firebase emulators. Let me check. Okay, so it is Firebase init emulators, and just make sure you select Firestore. We don't need to select the another one. We just want to use the Firestore emulator, and just download the emulator. And as you can see here, it configured the port. For me, it's using the port 19 to connect to the database, and for the UI, it's using port 9090. Okay, and we can configure this as well using the Firebase JSON file here. So you can change the port in here if you want. Currently, it uses these ports. Okay, and now we can simply run Firebase emulators start. Okay, so this will start the emulator here, localhost 9000, and this is for the UI. So let's copy this. And also by default, it will allow all the reads and writes inside this localhost emulator. We can also define the write rules if you want from this Firebase.json file. Just take a look in the documentation if you want to configure the security rules. Okay, so we have, let's try to run this here. Let me pass this. Okay, now it is running, as you can see. Okay, and the next step is to click this Firestore database from the admin dashboard in the Google server, console.firebase.google.com. Select this Firestore database from the side panel, and basically we need to create the database first. Okay, so here it provides the options to start in production mode or in test mode. So in production mode, it will set the security rules to false for the read and write. So we need to basically configure it by ourselves later. Maybe we only allow read and write if the user is authenticated. Okay, we can use Firebase authentication for the authentication, but we will cover that in another video. Okay, for us, let's just use the test mode in here. So the default security rules will be 1 month for the next 13 days. So we will be able to read and write for the 1 month. Okay, so click next, and then we need to select the location. You can select the location that is nearest to you, but in my case, I'm just going to use this name 5 US Central and then enable this, and then it will create the database. Okay, now the database is created in the cloud. That's it for all the prerequisites and setup before we can create the project in Xcode. Okay, now let's just open Xcode, create a new Xcode project, select iOS, and then this app template, click next. For the product name, I'm going to give the name of inventory tracker. Okay, just make sure this bundle identifier here, com.alvinluxury inventory tracker, is same with this one that we have created in the Firebase, com.alvinluxury.inventory tracker. Okay, they need to be the same. And remember that they are case sensitive. Okay, and now just make sure to select the interface to SwiftUI. You can uncheck the core data and then include tests. Click next to create the project. Save it anywhere you want. In this case, I'm just going to set it in the desktop. Okay, let me just close the preview, as using Firebase with the preview does not really work currently. Okay, now here, if you want to fix your bundle ID again, you can go in here. And the next thing is here, this is the Google Service Info.plist that I have downloaded from here. So you can still go to the settings and then download this from here. Okay, so basically you need to copy and paste this into your project. Okay, just add it to the inventory tracker target. Okay, then after that we need to configure Firebase the first time that we run the app. But before that, we need to add the Firebase SDK using the SPM. So click the file, add package in here, and see SDK instruction in here. Add Firebase SDK. So basically, we need to copy this URL, and here in this panel, just paste this. Okay, it will show this Firebase iOS SDK, and then just click add package. Okay, so basically, as this Firebase SDK is quite large, you need to wait for this. Okay, it is quite a long wait, and it finally finished fetching the data here. And now we need to select the product that we need to add. So there are many other features that we can use, but for this video, we just going to add the Firebase Firestore. Okay, and then Firebase Firestore Swift. So these two. Okay, Firebase Firestore and Firebase Firestore Swift. Just click add package. Okay, and as you can see here, it added this Firebase iOS SDK as the package dependencies. Okay, nice. Now the next thing is basically we need to configure the Firebase app when the app did finish launch is invoked. And as you can see, this is a SwiftUI based app, and the main entry point is here, this struct. So basically, we need to connect application delegate to this SwiftUI app. So here, let's just import UI kit first and create a app delegate class with the type of NS object and make it conform to the UI application delegate. Okay, and just implement this one application did finish launching with options. Make sure to return true. And next we need to import Firebase here. And the first thing that we need to do is we need to call Firebase app.configure. Okay, and that's basically the thing that we need to do to configure Firebase app. And next, we need to go to this inventory tracker app and then connect this app delegate using UI application delegate adapter. This is a property wrapper. So we need to pass the type of the app delegate. So we can pass app delegate itself. And let's make it this private for app delegate. Okay. And now let's try to run this for the first time. Just put a debugger here in the Firebase app.configure line and select the simulator. We select iPhone 13 and build and run this. This will take some time to build because there are quite a lot of dependencies here, gRPC and Google Utilities and the others. As well, here it uses the protobuf as well. So just let's wait for it. Okay, now the app runs, and as you can see here, it triggered this breakpoint firebase.app.configure. So we're certainly sure that this code is invoked. Okay, now let's try to resume this. Okay, there are no crashes as well. So that's it. We have configured the Firebase. So the next thing that we need to do is we need to configure the Firestore here to use the local host when the target environment is simulator. Okay. So with this, it should be able to connect to the local emulator suite without hitting the database server only when the target is simulator. Okay. So first we need to get the Firestore settings. Just type Firestore settings. Okay. Next, we need to use pragma here, conditional pragma. If target environment simulator, okay, we need to set the settings.host to localhost 9000. Okay, as you can see in here, my port for the Firestore local emulator is 9000. So if yours is different, just make sure to use the correct port. Okay, probably it will be 8000 in your machine. Okay, and then set the settings is persistence enabled. Remember that Firebase supports offline Remember that Firestore supports offline features, so it will store the data when you are offline. But for us, because we are hitting the local emulator, which will run even when we are online, we just set the persistence to false. Okay. And next we need to remove the SSL because we are connecting to HTTP in here. So just set this to false. Okay. So that's basically it. It's just an if in here. And next we need to configure this Firestore settings to use these new settings that we provide. Okay. That's it. And remember, as we are using HTTP, we need to also configure the app transport security settings here in the info plist. Select these targets and then select this info tab and just add a new key in here and use app transport security settings, type that and then select this one. Okay, and click on this and then add a new key value, select allow arbitrary loads. Okay, and this is a boolean, so let's set it as yes. Okay, so it can load it can make a request to the HTTP server. Okay, that's basically it for this configuration. So before we can continue, let's talk about how we can structure data using Firestore. Okay, so let's go back to the emulator suite localhost here and select Firestore. So to store data in Firestore, first we need to define the collection. This is similar to a table in a SQL database. So let me define a collection of inventories. Click next. And basically to store the data, the row, we need to create a document here and we need to provide the document ID. This is similar to the primary key in a row in SQL. And then we need to provide all the fields. And remember, this is a schema-less database. It's a NoSQL, so we can add any field anytime that we want. But remember, when you already roll out your app in production using an existing field with a specific type, remember that you don't want to change that. You remember that you don't want to change that because it can break the app that is already rolled out in production. Okay, so here I created a new row document and it generates this primary key, this document ID. And let me add a field here. First, let me add a timestamp, create that, and select the type to be timestamp and updated add as well. The type is timestamp. Okay. And for the other fields, give it a name of name, string. For the value, let me give MacBook Pro. And the other one is quantity. And let's use number for this. Let's give it a value of 1. Okay. And then just click save. So it creates this collection of inventories and with one document here. And here, this is the MacBook Pro. And I also find this article that provide a good diagram for this Firestore schema database model. So basically, here's the collections, users, and this is all documents. So one thing that you need to know is that each of these document can have a nested sub collections if you want. Okay. So basically here, let me go back here. For each of this document, you can create a nested sub collection if you want. Okay. So that is one thing that you need to know. But for this video, we just have a simple flat structure, simple inventories for now. Okay. But remember, you have the option to use sub collections, nested sub collection with Firestore. Just please refer to documentation if you want to learn more about it. Okay. And now we have the inventories and the document. Now let's go back to Xcode and create the Swift model. Now let's create a new file, new Swift file, and give it a name of InventoryItem. Okay. So here let's import Firebase Firestore Swift because we are going to use a special property wrapper. for this. And then next, let's declare a struct, give the name of inventory item. Okay, and make it conform to identifiable. So we can use this in SwiftUI list or for each. And next one is, let's also make this codable. Okay. Okay, so the first property we are going to define is the ID. But for this, we are going to use this special property wrapper, document ID. So when we use this document ID, every time this property is, so first we need to make this optional. And every time this is nil, Firebase will automatically generate the document ID for us. Okay, this will be unique and using the Firebase documentation, Firebase ID documentation standard to generate the ID. Okay, and next we also need to define the created at. Okay, this will be an optional date, and then we are also going to use this special property wrapper server timestamp. So when we use this server timestamp, and then when the date is actually nil, Firebase will automatically inject the timestamp when the data is synced to the server. Okay, it will use the server timestamp at the time when it syncs the data to the server. Okay, and next is updated at. This is also going to be optional date with server timestamp. Okay, so it will use the server timestamp when it writes the data to the server. And next we going to have the property for the name, string, and the quantity with the type of integer. So these are all the properties for the inventory item. Okay, so all of these properties have one-to-one mapping to this document created at name, quantity, and updated at. You might be wondering why the ID is not being shown in this field. So because we are using this document ID property wrapper, this won't be shown in the field. Instead, the document ID will be this document ID. Okay, so we don't have to store the additional ID field here. Nice, right? Next, let's change this to var. I think it's better to use var instead of let, so we can mutate it easier later. And let's try to show this in a SwiftUI list. Let's go to this app first, and let's wrap this content view in a navigation view. So to query the data from the Firebase Firestore and listen to the changes, whether a document is being added, edited, or removed from the collection, we can use a special property wrapper from the Firebase Firestore ViewModel. So let's import Firebase Firestore Swift. Okay, and we can use this FirestoreQuery here. Basically, we need to pass the collection path, so the type must be an array of decodable. So in our case, the inventory item already conforms to codable, which literally conforms to encodable and decodable. Okay, so for the collection path, just pass this inventories collection. Okay, inventories. And let's make this private var, give it a name of items, and the type must be array of inventory item, array of decodable. Okay, so this is very simple, right? Otherwise, we need to manually add a snapshot listener, or maybe we need to use a get API to get these documents. But with this FirestoreQuery, this will just works without us managing the snapshot listener by ourselves. Okay, so let me pass list items here, text. Let me use string interpolation, and then let me show the name, and let me show the quantity as well. Okay, so let's try to run this, build this. Let me put this side by side in here. Okay, the build succeeded, it runs, but there is no data. So if you encounter this issue, there is no data when you are connecting with the local emulator suite, just make sure you go to the overview and check this. Okay, so currently it uses pending tracker 9710A. Okay, but actually my app has different project ID here. So first, to know the project ID, so this is inventory tracker, right? And let's go to the terminal. Okay, just let me open a new tab. We can use this Firebase projects list. Okay, so currently I'm using spending tracker. Sorry, that's the wrong one. So this is the right one, inventory tracker. Okay, FCO0C9. So let's copy this. Okay, and set the project to use this one. Firebase use. Okay, now it's using this project. But actually, if we try to refresh in simulator, it still reflect to the 9710A. So we need to stop the current emulator and then start it again. Okay, let's refresh this. Okay, now it's referring to the inventory tracker, the correct one. And wow, it deleted the previous collection. So let me add this inventories. Okay, so I populated the document again. Let me save this and let's see. Nice. As you can see, it shows the data here, this single document, MacBook Pro with a quantity of 1. I forgot this closing parenthesis. Okay, nice. We're now able to query the data, show it in the Firebase list. Okay, now let me show you here. Let me open the emulator suite side by side here. Now if I change here, let's say I might modify this to MacBook Pro 14, save this. As you can see, it updated the SwiftUI list immediately. Okay, because this FirestoreQuery underneath this FirestoreQuery, it add a snapshot listener for us. Actually, if you want to take a look at the source code, so yeah, this is very handy for us to use. Makes the development so much easier. Okay, so if I change the quantity, then boom, it got updated in here. If I try to, let's say, delete this document, boom, it delete the document in the UI as well. Nice. So using this FirestoreQuery just works like magic, right? We don't know the underlying mechanism to query this and as well as adding the snapshot listener. But I encourage you to take a look into documentation here and understand how we can use to query the data manually, right? So here, basically you can get the data using this API. Yeah, this is harder compared to using that, but basically here you will be able to understand how this property wrapper works under the hood. Okay, so here for getting the real-time updates as well using the snapshot listener. So basically, when you are building an iOS app using UIKit, you probably need to use this API to get the document or listening to the real-time updates because it doesn't provide such mechanism like the one in this SwiftUI. Okay. So next, let me show you how we can display the error message in case this Firestore query fails. Probably it can fail because it fails to decode the data. Okay, so basically in here, let me use a VStack. Move this inside a VStack, and I'm going to only show the list when the count of the items is larger than 0. Okay, so basically this is a property wrapper, and we can get the projected value using this dollar prefix items. Okay, so this will expose the configurations, and here there are several properties: predicates, error, and path. And here's the error. So if any errors occur, they will be exposed in here. Okay, this is an optional, so we need to use if let. Okay, so the error exists. We just show error.localized description. Next, let's try to simulate when the inventory item fails to decode. Let me change this to integer. And I think I have deleted the data in this local emulator. So let me try to edit again. Okay, so now I have added the data. We need to recompile that now. Okay, I'm gonna compile that, and it should show the error, I think, because the type of the name now is integer. Okay, the data can't be read because it isn't the correct format. Okay, so basically it will show the error. In this case, it fails to decode the data because of the invalid type of the name. So let's change this back. Okay, so now we have successfully create the mechanism to show the error when this query fails. So next, let's implement the real-time editing feature for our app. So we should be able to update the inventory item in real time. First, let's declare a name here for the closure parameter item, and then remove this text, and let's declare a text field. Let's pass the name as the title, and for the binding, let's declare a proxy binding with the type of string with custom getter and setter. For the getter, we can simply return item.name, and for the setter, this will pass the new name for us. In here, basically we need to update the document in the collection, passing only the name. So to do this, let's declare a helper method, private func update item with parameter of inventory item and data with the type of string any. And then in here, first we need to grab the ID item.id. This is optional, so let's use guardlet. Next, we need to have a reference to the collection DB of inventories. So let's declare a private let DB and then use Firestore. I think we need to import Firebase Firestore first. Okay, Firestore and then .collection. This will return the collection reference. So we need to pass the inventories collections path. Okay, so we have the collection reference for the collections for the inventories. Now let's copy the data into a mutable var here, data, and then let's inject the data with the updated that. And we want to use the server timestamp for this, so we can use field value dot server timestamp. Okay, make sure to initialize this. Okay, and then basically we need to invoke db. So this is the inventories collection, and then we need to get the document reference using this document, passing the ID of the item. So this is the document reference. From here, we can invoke update data and then passing the underscore data containing the updated timestamp as well. Okay, this should update the item. Make sure we invoke this. So let's invoke update item, and for the key name, let's pass the new name here. Okay, that's it. Now we need to try this. Let's build it again and run it. Let me put it side by side here with the local emulator admin. And let me change here MacBook 14. As you can see, it got updated in real time. Okay, MacBook Pro 14, MacBook Air. Amazing, right? Now let's do the same for the stepper. Okay, to update the quantity. We have the text field. Next, let's declare a stepper. I think we can use this one for the title. Give it a name of quantity. And let's show the item the quantity as well in the UI. And for the value, we need to create a proxy binding integer with custom gather and setter as well. So for the gather, just return item.quantity, and for the setter, we can simply invoke update item, passing the item, and for the data, quantity with the $0. Okay, and for the we also need to range the stepper here. So we only want the user to pick between 0 as the lower bound, and let's choose 1000 as the maximum upper bound. Okay, let's try to build. It succeeded. Let's run it in the simulator now. Okay, let's try this. Let's update the quantity. Okay, 15, 16, 90, 20. Okay, it got updated here in the dashboard in real time. What is this line? Let's fix this. So, oh, I think we should put this text field and stepper inside of his tag. Okay, so let's move this. Okay, let's try again. Nice, now the separator got removed. This looks good, but let me also configure the font to use headline. And let me disable the autocorrection here. Let's pass through for the disable autocorrection. So it won't autocorrect when we input the name in here. Okay, so let's see the result again. Yeah, now this looks good. Next, let's implement adding item feature to this app. So let's put a toolbar with a navigation trailing button for the user to add the item. And let's populate the data with just a default placeholder value for now. Okay, so first let me create another private function, give it the name of add item, and let's declare a constant item and then initialize inventory item, and let's just use the placeholder name new item, and let's make the quantity as 1. Okay, and basically for adding the item we need to use the collection reference of inventories db and then invoke add document, this one, from value of encodable. Remember that the inventory item conforms to codable, which means it conforms to encodable as well. Okay, it is a throwing method in here. So let's pass the item, and let's use try optional here. Okay, and basically for the ID updated and created at value, it will be generated by the server. Okay, so we have this method. Now let's add the toolbar in here. So in this p stack, add a modifier toolbar. Okay, and let's also add a navigation title. Before I forget, give it a name of inventories as the title. Now inside the toolbar, let's declare toolbar item. And for the placement, let's put it in the navigation bar trailing. Okay, so it will be in the right side. And for the content, let's put button with the title. Let's just use this plus. And for the action, let's just invoke add item. Okay, and let's set the font as title, I think, to make it bigger. Okay, so let's try this. Okay, now we have this plus button here at the top right of navigation bar. Well, let me try to click plus. Nice. New item got added in here, and as well as here in the dashboard if you see. So we can edit new item 1, quantity of 2, 4, 5, add more item, new item 2, get the quantity as well. Okay, that's it. We have implemented adding a new document to our app. Now let's implement the delete feature for the inventory item. First, we need to refactor this to use for each inside the list. So here, let me delete these items in and then use for each. And here I'm going to pass the items item in. Basically, I'm going to move this v stack instead this for each, and make sure to remove these items that is being passed to the list as the parameter. Okay, so with for each we should be able to access the delete modifier. Okay, so basically this will pass us the index set in here. So before we do anything in here, let's also declare a private method for deleting the items. Okay, private func on delete, and I'm going to pass an array of inventory item in here, as well as the index set. Okay, and basically here I'm going to loop this index set, index for index in index set. So here we need to grab the ID using guard-let ID, and we have the array of the items as well as the index. Okay, pass it as a subscript and then access the ID. This is optional. And then if it fail to find the ID in this for each, we just continue to the next element. Okay, and basically in here we can invoke db.document passing the ID and this delete. Okay, so this will delete this document reference for this item ID. Okay, that's it. Now we need to invoke this in here. So I think we can just invoke this using on delete, passing the items, and for the index passing the $0. Okay, this should delete the item. Let's build and run to test this. Okay, now we should be able to swipe here. And let's see, let's delete this. Okay, it got deleted as well in the local emulator admin. Let me also delete the new item too in here. Okay, it successfully deleted the item. Let me add another item. So other than swiping, let's also add a edit button at the navigation leading here inside the toolbar to toggle the edit mode. Okay, so with the edit mode in place, we should be able to also trigger the lighting by pressing the button for each row. Okay, so let's take our toolbar item with placement of navigation bar leading. And for the content inside this toolbar item, we can use this edit button. So basically it's a button that toggles the edit mode environment value for us. Okay, and then let's just make this as a one liner, I think. Okay, let's run this. Okay, there's now the edit button here at the navigation bar leading. Click it. Okay, this will trigger this delete button here. You can click and then click delete. Okay, it deletes the item. Nice. That's it for the delete feature for this app. Okay, we have successfully implemented the CRUD functionality to this inventory tracker app. But if you see now, all the logic is inside this view, and I think we should refactor this, right? It should be in a separate object. Okay, so let's move this into a separate view model. Okay, all of this logic to add, update, and delete the item. So let me create a new C file, give it a name of inventory list view model. Let's open the content view, and let's open the inventory list view model side by side in here, and let's import SwiftUI, import Firebase Firestore, and let's declare an observable object of inventory list view model with the type of observable object. Okay, and for now let's move this db here into the inventory list view model, and then let's move all of this as well to here. Let's remove this internal, remove all the private, so we can call this from the view. Next, let's declare the view model reference using state object. Okay, private var view model vm inventory list view model. Okay, I'm just going to initialize it. It doesn't have any dependencies for now. Okay, this is being hard coded in here for the Firestore collection DB. And in here we can simply invoke vm.onDelete, vm.addItem, vm.updateItem quantity here, vm.updateItem name. Okay, now we have cleaned up the view, removing all of these methods in here to inventory list view model. Now let's make sure it runs. The build still success. Okay, the build succeeded. Now let's try to make sure the functionality works. Edit the item. Okay, updating the quantity, adding a new item, deleting an item. Okay, everything still works. We have successfully refactored this to a inventory list view model. Okay, so for the final feature, we are going to add the sorting capabilities to our list. So we should be able to sort by the updated tab, created tab, name, or quantity. in descending or ascending order. So the way it works is basically this item configuration here, dollar items, it exposes these predicates. So this is a query predicate. And basically every time we assign this, so there are several options. Basically we can filter, we can limit, we can order. So in a production environment, this approach that I currently use is not very scalable, right? Because this will fetch all the data, right? So if you have like thousands of data, right, it will fetch all of the data in one go. So it will increase your query cost. Remember that this is a managed service, so there's a pricing for querying the data as well as the network size, right? When you receive all the large response. So maybe you can limit the value to maybe only 100, 1000. So there are options, right? You can also probably filter it by the property. If the quantity is equal to 10, or it's also profile is greater than, it's greater than 0. Okay, so here we not going to show all the item that is currently out of stock, right? But in this example we are going to only use this order by, right? So remember that when you are using all of this, you might be required to declare a composite index in the database admin. Okay, but I won't be covering all of this where and the other predicates, query predicate that we can use for this. I'm just going to cover the order by. Okay, so if you're interested on another video on using this order filtering predicates using where the others creating composite index, please comment in the video below. So maybe if there are a lot of comment, I will be making a video about that. Okay, so let's move on to implement this sorting by feature. The first thing that we need to do is let's create a new Swift file, give it a name of sort type. Okay, so here let's declare an enum sort type and make it the value as string for the raw value, and make it also conform to the as iterable. For the case, let's create that, updated that, name, and quantity. And let's also define a compute property that we can use to show the item in the picker, segmented picker. So just use switch cell. Okay, updated. Let's begin by created that. Here we just return created that text. Let's copy this 4 times. Updated that, and name finally the quantity. Okay, now let's try to build first. Okay, the build succeeded. Next, let's go to the ViewModel here. I already opened this and declare several published properties. First one is publish var selected sort type. And for the default value, let's assign sort type dot created that. And second one is publish var is descending with the default value of true. Okay, we have these two published properties. Now let's go back to the content view. And let's declare a private var in here. Let's give it a name of sort by section view that returns an opaque view, some view. So in here, let's declare a section, and let's declare a disclosure group For the label, let's just return sort by. And for the content, so basically this with this disclosure group, this section can be expanded or collapsed. Okay, so it can be hidden or shown. And here, let's declare a picker. And let's use this pass sort by as the label. And for the binding, we can simply use pm dot selected sort type. And for the content, let's just use for each. And let's pass the sort type all cases. This will contain all the sort type cases. And we need to provide the ID because it doesn't conform to the identifiable protocol. In this case, we can just use the raw value as the identifier. Okay. Now we get the sort type in here. Let's just show it in a text, short type.text, and make sure to add the tag in here and pass the sort type. Okay. Okay, we have this. Let's build first. Okay, the build succeeded. Now we can put this as the first item in the list, sort by section view. And next, I want to also make this list style as inset group here explicitly. And in here, I want to refactor this for each items to another property. So to make this body more compact, okay. And let's give it a name of private file list items section view, some view. And let's copy all of this to this list item section view. Okay. And then let's wrap it inside a section as well. Okay. So now it is being inside a section. And use this list item section view here for the second section. So actually, if you use section, this will increase the accessibility for the list. Okay. Now we have these two sections. Let's just try to see the UI first. And let's try to expand this. Okay. This is the picker. So currently it uses this picker style. Let's change this to a segmented control style. Okay. So let's go back in here. The picker, we can change the picker style using the modifier, passing segmented. And let's also add a toggle for the is descending. So in here we can pass is descending as the label, and we can bind it with the vm.isDescending publish property. Okay, let's run it again. Okay, expand it. Nice. Now we have this. Created that, updated that, name and quantity. It's quite a bit of truncated in here. Maybe we have too many sort by criteria. Okay, but it does works. Let's go back. Okay, so we have created the UI for the sort by. Now let's make a default value for this Firestore query, right? So basically in this Firestore query, we can also pass the predicates as the property. This accepts an array of query predicate. And by default, I'm going to pass this same value in here, greater that for the field, and is descending of true. Okay, but because I cannot access this inventory list ViewModel instance, I will need to hardcode this to create that. Let's use the sort type, create that raw value, and for the descending, it's going to be true. Okay, so that's the default sorting behavior that we want. Next, we need to update these predicates whenever one of these value here, this publish property, get changed, get updated. Okay, so to do that in SwiftUI, we can simply use the onChange modifier, but before that, let's create a computed property here inside the ViewModel for predicates that with the type of array of query predicate. And in here, this will be computed. So we just return an array of order by. Here we can use selected sort type dot row value, and we can also use the is descending publish property. Okay. So we need to update the predicates for the FirestoreQuery using this compute property. So to do that, we need to use this on change of. So we can pass pm dot selected sort type, and let's create another private function in here on sort type changed. Okay, and basically we can access the configuration using the dollars here for the FirestoreQuery, and this is the predicates. To update it, we just invoke vm.predicates. Okay, so whenever one of these value change, we're going to invoke. Let me make this a bit shorter using a trailing closure. Let's ignore the parameter and just invoke on short type change. Okay, and also let's copy and paste and change the second one to is descending. Okay, so this will trigger the previous update whenever we change the sort type or this descending toggle. Now we need to test this. Build and run. Okay, now let me rename this to AirPods Beats. Okay, so this is the default ordering. So created that. So let me change that to name here and toggle this. As you can see, this is ascending and this is descending. And for the quantity as well here, so this is the descending, start from 5 and then it will be 1. If I toggle it back, it will start from 1. It's going to ascend to 5. Okay, now we have successfully implemented the sort by feature into our app, and with this we can basically order the list the way that we want. Nice, right? So before I conclude this tutorial, let me show one minor thing that maybe we can fix in here. So let's say I use this sort type of name, and in here, as you can see, I can edit this in real time, right? So let's say I edit this. So if you notice earlier here, when I change this, it jumps around, right? This cursor. So I think this can be distracting to the user, as they maybe there are a lot of items in the list and they are editing, and the row that they are editing is jumping around, right? So I'm thinking to make this editing name to only commit to the database when it finish editing. So let's say they press enter in here, it will only update the value after they commit the data. Okay, so let's implement this. Okay, so the first thing that we need to do is let's go to the inventory list view model, and let's declare a published var edited name to store the currently edited text in the text field. Let's assign with the empty string, and in here let's declare the method. Okay, on editing item name changed. So this is accepts the inventory item as well as is editing with the type of boolean. Okay, so if it is not editing, right, basically this when the user press return on the keyboard, we're going to check if the item.name is equal to the is not equal to the edited name. Okay, this will be updated every time the user types this edited name publish property. So only if this is not equal, we're going to invoke update item, passing the item, and for the data we're going to pass name edited name. Okay, and make sure we set the edited name back to MC string. Else, we're going to set the edited name to item.name. So this else will be invoked when the user put a focus into a specific text field. In this case, we're going to assign the edit name binding here with the current selected item name. Okay, let's see how this works. So basically, in this text field, in the setter of the binding, we need to basically change this to invoke ViewModel vm dot edited name to the new name. So every time this gets updated, it will update the edited name published property. And I think I removed too much thing. Okay. vm.edited name 0. Okay. Then basically we need to depend on this on editing change. Okay. And in here we can simply invoke vm.on editing item name change and pass the item and the is editing. So basically the closure will give us the is editing boolean in here that we can pass. Okay, now we have this. Let's try boolean run. And okay, the app runs. Let me select name here. So here I'm currently editing bits, right? So let's say here when I change this bits, it doesn't get updated in real time because I haven't pressed enter return the keyboard. So let me edit here and let me change the name to maybe AAA. So now it doesn't jump around, right? Before it's going to be jumping around to the bottom. So when I press enter, then it will get updated and the ordering will be respected. In this case, the ABC comes after the AirPods in the descending order. Okay, now before I conclude this, I forgot that I think we should test this using the server, right? So here, let me comment this for now. Okay, now let's try it. Now let's try to add a new item. Okay, it's being added nicely in here. Add two more. Okay, select this one, new item, change this, probably this one. Okay, got updated in real time. If we see, nice MacBook. Okay, let's try to delete. Okay, this actually works in the actual Google server. Okay, so now we are sure that this actually works in the production environment, right? So let's comment this again and use the local simulator in the development. So yeah, basically that's all for this tutorial for the building of Firestore inventory tracker app using SwiftUI. And as you can see, using this Firestore, it really helps us on prototyping a product, really, because we don't have to provision and manage our own database. And we can just basically use this. But you need to be careful when you are deploying this to production. Make sure your data, your schema, the way that you define the collection and document is scalable, right? So basically try to avoid querying a very large data in one go, right? Should try to batch the data, maybe using a pagination that using that query predicate of limit in your app. Okay, so that's it. Until the next video, let's keep on being a lifelong learner. Please like the video if you like and subscribe. Thank you.